So now I'm going to walk through number 7. It is very, very similar to number 6. So if you haven't watched that video, watch that one first. And then I would recommend trying this one without watching this video. But if you have and either you still can't get it or you want to see the answer, that's fine. So just like before, we're going to draw a picture. So I'm not going to pretend like I can pronounce that word. So the something. Cliff divers provide daily entertainment for crowds at Acapulco, Mexico. As a group of professional high divers, they dive off a cliff at la something and fall 45.1 meters or 148 feet to the water below. More than an act of bravery, the cliff divers must also time their dives so that they hit the water when the crest of an incoming wave has arrived. Determine the speed with which Pedro must run off the cliff in order to land in the water at a horizontal distance of 17.8 meters from the edge of the cliff. So just like before, this is very similar. So here's the cliff, there's Pedro. We know that the height is 45.1 meters. So again, that's our delta y is equal to 45.1 meters. And again, remember, this is in the negative direction because he's falling. And they also give us our delta x, which he needs to make it, this is not drawn to scale, he needs to make it 14.8 meters. Okay? So, and just like before, we're going to go through our givens. So in our y direction, our delta y is negative 45.1 meters. Our velocity in the y direction initial is equal to 0 meters per second, because again, he's running off horizontally, so that y is 0. The velocity in the y direction is 0. And our acceleration in the y direction is negative 10 meters per second squared, because again, that's gravity. So, and then in our x direction, our delta x is equal to 17.8 meters. We know our velocity initial in the x direction is equal to our velocity final in the x direction. And we know that because our acceleration in the x direction is going to be 0. Again, this is just, we know this because with our projectiles, as long as we're neglecting air resistance, which we are, we're going to assume the acceleration is 0 in the x direction. So now, what we're trying to find is our velocity final, which is equal to our velocity initial, both in the x direction, which is equal to, we don't know yet. So again, I set this up just like before, so if you've done number 6, you should be able to follow the steps that you use in number 6 to get there from here. But in case you still aren't sure, we'll go through the steps. So again, remember, it doesn't matter how fast Pedro runs. He's going to hit this ground level at the same time, no matter what. So we know Pedro only has enough time as it takes him to free fall from the cliff. So our delta y, again, this is equation number 3. Our delta y is equal to velocity initial in the y direction times t plus 1/2 times acceleration times time squared. So again, I'm going to go through this a little bit faster because it is exactly the same as the last one. So I'm not going to spell out all of my steps. Oops, not -5, -10. I was skipping ahead. And then if I divide both sides by -5, it gives me 9.02 seconds squared is equal to t squared. And if we take the square root of that, that roughly becomes 3 seconds is equal to t. So that's our time that he has to fall that distance. And so just like before, our velocity average is going to be equal to our delta x over our delta t. Which our velocity average is equal to 17.8 meters over 3 seconds, which is equal to 5.93 meters per second. And that's our final answer. That's our velocity in the x direction. I hope this helps, and once again, good luck on your test on Friday. Let me know if you have any questions.